All right, so welcome to today's kind of study session thing. Today we're doing trig identities. Yeah, once again, this is kind of like a study session format. So I highly encourage you guys to pause the video, try the questions out yourself, and then once you're finished, you can resume the video and kind of, we can compare how we did the questions, okay? Yeah, let's take a look at this one here, this first question. So we've got 1 minus cos squared x times cosecant x times secant x. We were trying to prove that that's equal to tan x, okay? So for any of these questions, make sure you're not kind of like manipulating both sides, okay? Just start with one side, work with that side. If you want, you can go to the other side and work with that side, but don't do anything like we're going to multiply both sides by this or so on and so forth, okay? Just work with one side at a time. So on this left side here, we've got 1 minus cos squared x. Can I change that a little bit? Well, what do I know? I know that sine squared x plus cos squared x is equal to 1, right? So you can almost imagine that, we take this cos squared x and brought it to the other side. That would give me sine squared x is equal to 1 minus cos squared x, right? So this first term here, I can rewrite that as just a sine squared x. And what do I know about this cosecant x here? I know that's equal to 1 over sine x, right? And secant, what do I know about that? That's 1 over cos x, right? All right, great. Now this sine x here, I can maybe just rewrite that as, like sine x times sine x times 1 over sine x times 1 over cos x. And here, notice this sine x and this 1 over sine x cancel out, right? So I'm left with what? I'm left with, well, top times top, bottom times bottom. Sine x times 1 is sine x, and 1 times cos x is just cos x. Well, what's sine over cos? That's just equal to tan x, right? So tan x is equal to tan x. Perfect, great. All right, next question over here. Okay. So we're trying to prove that this left side is equal to that right side once again, right? So let's simplify the numerator a little bit, okay? Sine x, there's not really much we could do with this. But what do I know about cotan x? Cotan x is cos x over sine x, right? And this cos x, I mean, there's not really much I could do with that. And then we're going to divide all this by cotan x. What is cotan x again? We said just now this is just cos x over sine x, right? Now, I'm dividing by a fraction, so we're going to just do the same thing here in the numerator, sine x cos x over sine x plus cos x. And whenever we divide by something, it's the same thing as like multiplying by its reciprocal, right? So we change that division to a multiplication, and we just flip the fraction, okay? So we can kind of rainbow method this now, okay? Kind of rainbow backwards here, okay? First of all, actually, before we even rainbow, this sine x and this sine x cancel out, right? So on this left, well, that first term here, we have cos x times sine x over cos x plus, and the second term here, we've got cos x times sine x over cos x. And now here, notice the coses cancel out, right? And here the coses cancel out. So we're just left with sine x plus sine x, which is just 2 sine x. And that's what we had to prove on the right side, right? Okay, great. Next over here, question C. All right, so let's take a look at this left side here. In the numerator, we've got 1 minus cos squared x. This is very similar to question A, right? And by now you should know that 1 minus cos squared x is just sine squared x. And in the denominator here, we've got tan squared x. I can rewrite that as sine squared x over cos squared x, right? And like before, we're dividing by a fraction, right? And whenever we divide by something, it's like multiplying by its reciprocal. So instead of dividing by sine squared x over cos squared x, it's like we're multiplying by cos squared x over sine squared x, okay? And now notice these two cancel each other out, so we're just left with cos squared x. Okay. Let's move on here to question D. All right, so let's look at this one here. On the left, we've got 1 minus, okay, and then on the numerator here, we've got secant x. What do I know about secant x? That's just 1 over cos x, right? And cotan x. What is cotan x? That's cos x over sine x. And in the denominator, we still have sine x, okay? And now notice these cos x here cancel out. So we're left with 1 minus 1 over sine x, and that's divided by sine x. Make sure your fraction lines are correct, right? Make sure this is not longer than the second one. And in the denominator here, we've got sine x. That's almost the same thing as sine x over 1. Okay? So once again, we're dividing by a fraction. It's like the same thing as multiplying by its reciprocal. So here we're going to have 1 minus 1 over sine x, and instead of dividing by sine x over 1, we're multiplying by 1 over sine x. Okay? So whenever we multiply fractions, the tops, the numerators multiply together, the denominators multiply together. So 1 times 1 is 1, sine x times sine x is sine squared x. Okay? Well, what is 1 over sine squared x? That's just cosecant squared x, right? Okay. Now let's think back to our identities here, right? Remember, we know what? We know 1 plus cotangent squared x is equal to cosecant squared x. Okay? So this looks kind of similar, but not exactly. It's almost like we brought this cosecant squared x to the left, so the sign changed, and then we brought that cotangent squared to the right, so then it should be a negative cotangent squared x, right? We have something like 1 minus cosecant squared x. That's going to be equal to minus cotangent squared x. So that tells me that this thing here is equal to negative cotangent squared x, which is what we want to prove on the right. Okay, so that's good. Let's go down here to question E. Okay, so this question here, we've got this big fraction, and in the numerator, there's no real identity that kind of pairs secant squared x with cosecant squared x, right? So let's just kind of start writing everything back in terms of sine and cos and kind of see what happens from there. Okay, so in the numerator here, we've got 1 over cos squared x plus 1 over sine squared x. And in the denominator, we've got, secant x, that's 1 over cos x. And cosecant x, that's just 1 over sine x. Okay, and here, actually, since we're multiplying these two fractions, top times top is just 1. Bottom times bottom is just going to be cos x sine x. So let's just write that real quick. We got cos squared x plus 1 over sine squared x. That's going to be divided by 1 over cos x sine x. Okay. Now this looks kind of awful. We're dividing by a fraction here, and we have two fractions in the numerator. But remember, when we're dividing by something, it's like the same thing as multiplying by its reciprocal, right? So instead of dividing by 1 over cos x sine x, we can multiply by cos x sine x over 1, which is just cos x sine x, right? So let's just write that real quick. We've got 1 over cos squared x plus 1 over sine squared x, and that's being multiplied by cos x sine x over 1. Okay, now we're going to rainbow method this. All right, so let me scroll down real quick. Okay, and so that's going to give me what? Well, the top multiplies the top, the bottom multiplies the bottom, right? So cos x sine x times 1 is cos x sine x, and in the denominator I have cos squared x times 1, which is just cos squared x, plus, and then here in the second fraction we've got cos x sine x times 1, that's just going to be cos x sine x, and in the denominator I have sine squared x times 1, which is just sine squared x. Okay, now we can kind of cancel this cos x with one of these coses in the bottom, and this sine with one of these sines in the bottom, right? It's almost like if you had, imagine like xy over x squared, right? You can cancel out this x here with one of the x's, with two x's down there, okay? Except in this case, instead of x, we've got cos x, all right? All right, and here we've got sine x instead of just x. So on the left, this first term, we've got sine x over cos x. And in my second term here, I've got cos x over sine x. Well, what is sine x over cos x? That's just tan x, right? And cos x over sine x, that's cotan x. And that's what we wanted to show here on this right side, right? So we're good, all right? Question F. All right, so let's look at this question real quick. Now, if we try to kind of expand this out real quick, right? Is that going to is that really going to be helpful? We're going to have something like cos to the 4x times, well, instead of cosecant, maybe we have like 1 over sine squared x minus cosecant squared x. And this looks like really awful, right? And there's no real like identity that I could really use here that's going to be all that useful. But what can I do here instead? I've got this cos to the 4x minus 1. Maybe I could try factoring using difference of squares and see where that gets me. Okay, so here we've got 2 plus difference of squares. That's going to be cos squared x plus 1 times cos squared x minus 1 times cosecant squared x. Okay, and here we know what? We know, let's take a look here. We've got, remember, let me write this down a little lower. Sine squared x plus cos squared x is equal to 1, right? So if you imagine that we take this 1 and we brought it to the left, so it becomes a minus 1, and we took this sine squared x and brought it to the right, so it becomes minus sine squared x, right? We're going to get what? Cos squared x minus 1 is equal to minus sine squared x, right? So here, notice we've got that cos squared x minus 1. We can replace that with a negative sine squared x, okay? So we've got 2 plus cos squared x plus 1. And we'll swap this out here for a minus sine squared x. And this cosecant squared x, maybe we'll rewrite this as 1 over sine squared x. And notice now we've got a sine squared x in the numerator and 1 in the denominator. We can cross these out here, okay? And so here we've got 2 plus, or actually, well, with a negative sign here, let's take that negative and bring it out here. Okay, we've got 2 minus cos squared x plus 1. And let's get rid of these brackets here. We've got 2 minus cos squared x minus 1. And 2 minus 1, that's just 1, right? Minus cos squared x. Well, what do I know? I know that from this identity here, if I just bring that cos to the other side, I'm going to get sine squared x is equal to 1 minus cos squared x, right? So instead of 1 minus cos squared x, I can replace that with just a sine squared x. And that's what I wanted to show up here, right? So we're good, okay? All right. So here we've got 2 fractions, and be very careful here in the denominator. You can't say this is this guy here is equal to cotangent x. Okay, you can't just kind of make up your own identities. Okay, the identity that you're kind of thinking about if you wrote something like this requires that you have a square here. Okay, so make sure to not do this. All right. Now, if you're looking at this very carefully, there's not too much we can do with the denominators. So what we're going to do actually is try to put them on a common denominator and see what kind of happens. All right. So here on this top here, I'm going to multiply this guy by a cosecant x. That's not cosecant. Cosecant x minus 1. And I'm going to multiply this guy by a cosecant x minus 1. Okay, the whole denominator. And here I'm going to multiply the numerator by a cosecant x plus 1. And here I'm going to multiply the entire denominator by a also cosecant x plus 1. Okay, what I do to the numerator, I have to do to the denominator. Okay, and same thing on this fraction. Okay, both fractions. So here on top, I have 1 times cosecant x minus 1. Okay, I forgot to put the brackets here. Let me do that real quick. Okay, so 1 times cosecant x minus 1, that's just cosecant x minus 1. Cosecant x plus 1 times cosecant x minus 1, that's almost like you can imagine you're undoing a difference of squares, right? That's going to be like cosecant x to the power of 2 minus 1. And same idea here, right? On top, you're going to have cosecant x plus 1. And in the denominator, you have like, you're like undoing that difference of squares. You're going to have cosecant squared x minus 1. Now, they have the same denominator, so you can put this all over one fraction. You have cosecant x minus 1 minus, okay, cosecant x minus 1, all divided by cosecant squared x minus 1. Now you're going to notice we have a cosecant x and a minus cosecant x, so those are going to cancel out. And you're going to get minus 2 divided by, all right, now at the bottom here we have cosecant squared x minus 1. Now we can do that identity that I was talking about at the very beginning, right? With the, because we know 1 plus cotangent squared x is equal to cosecant squared x. So if you can imagine bringing that 1 to the other side, you're going to be left with cotangent squared x is equal to cosecant squared x minus 1. And that's what we have in the denominator. So we can replace that in the denominator with cotangent squared x, okay? But remember, cotangent squared x, all right, cotangent squared x is just 1 over tan squared x, right? So we can write this as minus 2 divided by 1 over tan squared x. And when we're dividing by something, we multiply by the reciprocal, right? Those are two same things, same ideas, right? So instead of dividing by 1 over tan squared x, we're going to multiply by tan squared x divided by 1, but anything divided by 1 is itself, so I'm not going to write the divided by 1. We're just left with minus 2 times tan squared x, which is what we wanted to show at the beginning. So we're good, okay? All right, let's look at question H then. Okay, cotangent x times cos x minus cosecant x. We're trying to show that that's equal to minus sine x. So cotangent x, that's going to be cos x over sine x, and that's going to be multiplied to cos x, right? Cos x over 1 maybe. And that's going to be subtracting 1 over sine x, right? Because cosecant x is sine x. And so if we multiply this first fraction out, we're going to get top times top is cosine squared x. Sine x times 1 is just sine x. Okay, and now we're left with this. But we have a common denominator here, so we can just kind of put this all over one fraction, right? Cosine squared x minus 1 divided by sine x. Okay, now remember, right, sine squared x plus cos squared x is equal to 1. So if you can imagine, we bring this 1 to the left, so it becomes a minus 1, and bring that sine squared to the right, that's going to become a minus sine squared, right? You're going to be left with cos squared x minus 1 is equal to minus sine squared x. So we can sub this numerator with a minus sine squared x, okay? So you're going to have minus sine squared x over sine x. We can kind of simplify this, reduce this to a minus sine x, right? This is almost like if you want to imagine it as a minus like x squared over x, right? You can just kind of cross that out here, okay? So you're left with minus sine x, and that's what we wanted to show at the start, right? Okay. Now let's look at I over here. So cosine squared x times cotangent squared x minus cotangent squared x. We want to show that's equal to minus cos squared x. All right. What do you notice here is we have a GCF, right? We can pull out this cotangent squared x, and we're going to be left with cos squared x minus 1. And once again, this is very similar to what we had in question H. Cosine squared x minus 1, we can rewrite that, right, as a minus sine squared x, okay? And this cotangent squared x, maybe we can rewrite this as a cos squared x over sine squared x. And here we have a minus sine squared x over 1, right? And so a sine squared in the denominator, a sine squared in the numerator. Those are going to cancel out. You're going to be left with a minus cos squared x over 1, but I'm not going to write the over 1. Okay? And that's what we wanted to show on the right. So that's good as well. All right, on to question J. Okay, oh my god. All right, this is kind of crazy. Looks kind of like complicated here. Let's kind of try to simplify this as much as we can. Well, what do I know here? I know sine squared x plus cos squared x in the numerator, right? That's an identity, right? You guys should recognize that by now. Sine squared x plus cos squared x, that's going to be equal to 1, right? So that's good. Let's write this numerator first then. We've got 1 minus secant squared x. And in my denominator, we've got two things here with a cosecant x, right? That's a GCF here. We could pull that out. So we're going to have cosecant x. And here we have secant squared x minus 1. And these look very similar. It's just like swapped, right? So maybe what we can do instead is we can just pull out a negative 1 here, okay, on the top. So that's going to be minus positive secant squared x minus 1. Okay, we just kind of factor out a negative sign. And then in the denominator, we have cosecant x times secant squared x minus 1. And now these two things match. We can just kind of cancel them out here like this, okay? So we have on top here, we've got minus 1 divided by cosecant x. But what is cosecant x? Well, cosecant x is just, well, let me write the cosecant x is equal to 1 over sine x, right? So instead of cosecant x in the denominator, we can write this as minus 1 divided by 1 over sine x. And when we divide by a fraction or divide by anything, it's the same thing as multiplying by. It's reciprocal, right? So instead of doing minus 1 divided by, we'll do minus 1 times, and then we'll flip this fraction as sine x over 1, but sine x over 1 is just sine x. So I'm just going to write sine x, okay? And you're left with minus sine x, which is what we wanted to show from the start. So that's good, okay? On to question K. Wow, this one got even worse. Didn't think that could happen. All right, so let's think about this real quick. We know, well, we know a lot of these, right? Cotangent x is just cos x over sine x. We know tan x is sine x over cos x, and secant x is 1 over cos x. So let's rewrite some of these terms real quick. Okay, so cotangent x is cos x over sine x. Here we've got times, I'll write this as cos x over 1, maybe, okay, just so we can multiply this a little nicer. And this is plus sine x plus sine x over cos x, and secant is 1 over cos x, okay? And in my denominator here, I've got cosecant x. I know that's 1 over sine x. Okay, so in my numerator then, I'm going to be left with cos squared x over sine x plus, I'll write this as sine x over 1. You'll see why in a second. Plus, and then sine x times 1 is sine x divided by cos squared x. And instead of dividing by 1 over sine x, I'll multiply this by sine x over 1. Okay? And now we have to rainbow method, okay? So this is going to get multiplied out here. So here we're on the first term here, we're going to have cos squared x times sine x divided by sine x times 1 is just sine x, plus here we're going to get sine squared x over 1. I'm just going to write that as sine squared x. Plus, and here we have sine squared x over cos squared x. Okay, now on my first term, these sine x are probably going to cancel out here, right? So that's going to give me cos squared x plus sine squared x plus, and sine squared x over cos squared x, that's just tan squared x, right? Okay, now once again, we have cos squared x plus sine squared x. You should recognize this by now. This comes out to 1, right? So you have 1 plus tan squared x, and this is an identity as well, right? 1 plus tan squared x, that's going to be secant squared x, and that is what we wanted to show from the start. Okay, so that's good. All right, question L. Okay, so we've got 1 plus cos x all squared divided by sine squared x. And you see on the top here on the right side, we have 1 plus cos x, and here we have 1 plus cos x squared. So I'm going to assume somehow in my denominator, I can find a way to kind of cancel out one of these 1 plus cos x's. So let's think about this. Well, maybe we could try expanding. I know sine squared x is, well, let's write this out real quick in pink. Okay, we know sine squared x plus cos squared x is equal to 1. So if I brought this cos squared x to the other side, I'm going to get sine squared x is equal to 1 minus cos squared x. Okay, so let's try expanding this denominator. So on top we have 1 plus cos x squared. In my denominator then, I'm going to have 1 minus cos squared x. And here actually, yeah, we can do a difference of squares in my denominator here, right? We have 1 plus cos x squared, and in my denominator I'm going to get 1 plus cos x times 1 minus cos x, and here we go, right? This cancels out here with one of these on top, so I'm going to be left with 1 plus cos x over 1 minus cos x. 1 plus cos x over 1 minus cos x, that's what I wanted to show here. Okay, so that's good. On to question M. Okay, 1 plus cotangent squared x over secant squared x plus 1 is equal to cosecant squared x. Okay, so in my numerator then, 1 plus cotangent squared x, I know what? I know that's going to be equal to cosecant squared x, right? And in my denominator then, we have secant squared x. Let's just rewrite, we'll keep it as it is for now. Okay, plus 1. Okay, cosecant squared x, what is that? That's 1 over sine squared x. And in my denominator, I have secant squared x. What is that? That's just 1 over cos squared x, right? Plus 1. Okay, and instead of dividing by 1 over cos squared x, I can multiply by cos squared x over 1, right? So let's write this as 1 over sine squared x times cos squared x over 1 plus 1. Okay, so we're multiplying fractions here. The top multiplies the top, the bottom multiplies the bottom. So we're going to be left with 1 times cos squared x is just cos squared x. Okay, sine squared x times 1 is just sine squared x, and we're going to have a plus 1. But what is cos squared x divided by sine squared x? That's just cotangent squared x, isn't it? And cotangent squared x plus 1, we know that's an identity. That's going to be equal to cosecant squared x. And that's what we wanted to show on the right. Okay, so that's good as well. All right, on to question N. Okay, so tan x plus sine x over secant x plus 1 is equal to sine x. All right, so there's not really too much I can do here. There's not a lot of like squares, a lot of identities I could use. So maybe we can try to rewrite everything in terms of sine and cos and see how that goes. So tan x is sine x over cos x plus sine x, and that's going to be divided by secant x, and now that's 1 over cos x plus 1. Okay, now in my denominator here, maybe I could try to put everything on a common denominator. So this 1, I'll just do 1 over 1, and I'll multiply the top by cos x, the bottom by cos x as well. Okay, so on the top here, I'm going to have, and maybe I'll put this on top as on a common denominator as well. Okay, let's do that for everything. So I'm going to multiply this top here by cos x and the bottom by cos x as well. So in my numerator, I have sine x over cos x plus sine x cos x divided by cos x. And in my denominator here, I'm going to have 1 over cos x plus cos x over cos x. All right. And here I'm going to kind of put these two on the same denominator here. I have sine x plus sine x cos x all over cos x. And this is all divided by 1 plus cos x divided by cos x. Now, we can divide this fraction by multiplying by its reciprocal, right? Remember, when we're dividing, it's like the same thing as multiplying by the reciprocal. So my numerator, actually, I'm just going to factor this real quick. 1 plus cos x, right? Divided by cos x. And now I'm going to multiply the numerator by the reciprocal here of this guy, this denominator. So that's going to be cos x over 1 plus cos x. Well, what do you notice here? I have a 1 plus cos x in my numerator, and I have a 1 plus cos x in my denominator. Those are going to cancel out. And here I have a cos x and a cos x. Those are going to cancel out. That's going to leave me with just sine x. Oops, I forgot the x here. Sine x, okay? And that's what I wanted to show from the start here, right? Over here. So that's good, right? Now, last but not least here, question O. All right, so for this question, we don't really have any identities, right? With a cubed. So that's going to be kind of like, that's not very helpful for us, right? But, you know, if you look at this for maybe more than a second, you might notice on top we have a GCF of sine, and on the bottom we have a GCF of cos. So we can factor out the sine here, sine x. We're going to get sine squared x minus 1. And in my denominator, I'm going to have cos x times cos squared x minus 1. Okay? Now, what do I know is that I know sine squared x plus cos squared x is equal to 1, right? And if I bring this cos squared x to the right, so it becomes negative cos squared x, and I bring this 1 to the left, so it becomes a minus 1, well, what am I going to get? I'm going to get sine squared x minus 1 is equal to minus cos squared x. Same idea, if I brought the sine squared x to the right and the 1 to the left, I'm going to get cos squared x minus 1 is equal to minus sine squared x, right? So I can substitute this thing in the brackets and this thing in the brackets. I'm going to have sine x times negative cos squared x. And then in my denominator, I'm going to have cos x times negative sine squared x. Okay? And now these negatives are going to cancel out, right? And here I have a sine x on top. I have sine x squared in the denominator. So I can cancel out this sine x with one of those two sines that are being multiplied together. And I can cancel out this cos with one of these two coses that are being multiplied together. So that's going to leave me with cos x over sine x. And what is cos x over sine x? That's just cotangent x, okay? And so that's going to kind of wrap it up for today's study session on trig identities. If you have any questions, if any steps were unclear, just let me know in the comments and I'll try to answer as soon as possible. If you have any other topics that you want to do a study session for, just let me know in the comments below, okay? Have a great day, guys. Bye.